In this video, I want to go over the definitions of voltage and current. So if you remember from a previous video, we said that in circuit analysis, we want to use some assumptions in order to simplify the circuits, right? But what was the end goal? The end goal was to create a mathematical model for the circuit. So to build the mathematical model, we must write the variables that we have in the circuit in terms of some measurable quantities. So what are these measurable quantities that we can define for our circuit? So the measurable quantities that we will use are voltage and current. So if we have a component that can be strictly modeled in terms of the voltage and current at its terminals, that means that we can use that definition or the relationship between its voltage and current to build the mathematical model. So if we have that for all the components that we have in our circuit, that basically gives us a way to create the mathematical model for the circuit. This has another implication too. So if we have two physically different components, but the relationship between the voltage and current at their terminals are exactly the same, for the purpose of circuit analysis, they act the same way. So if we have, let's say, a component in box 1, and if we have another component in box 2, right? So even though we might not have access to what is inside box 1 and box 2, but we have two terminals, right? I will go over these in more detail at a later slide too. If we have the terminals and we know what is the relationship between the current and the voltage, so this one is V1, this one is I1, this one is, let's say, I2 and V2. So if the relationship, so let's say I1 and V1, if the relationship is equivalent for I2 and V2, these two boxes, for the purpose of circuit analysis, they behave exactly the same way. So now that we have this general understanding, let us see how voltage and current are being generated in the first place. So to answer to that question, we need to see about the characteristics of the electric charge. So there are several characteristics for the electric charge. The first one is that the charge is bipolar, which means that the electrical effects are described in terms of both positive and negative charges. So this is the first characteristic of the electric charge. The second characteristic is that the electric charge exists in discrete quantities. Basically, even though electric charge can be very, very small, right? But the amount of electric charge is not a continuous variable, right? You have a hard limit, which is the amount of charge at the what is called the elementary charge, which is 1.6022 multiplied by 10 to the negative 19 coulombs. So any electric charge is basically a multiple of this elementary charge. So this was the second electric charge characteristic. The last one states that electrical effects are attributed to both the separation of charge and also the motion of charge. So depending on the electrical effect, if it's caused by separation between positive and negative charges, that results in what we call a voltage. If it's as a result of electric charges moving, that results as a current. So that is the distinction between the voltage and current. So for voltage, you separate positive and negative charges. So as you can see in this figure, for this battery, for example, we have the positive side here on the left and we have the negative side on the right. Because of this separation, we have a voltage across the two terminals of this battery, right? On the other hand, if we connect the two sides together, right, whether it's via a single wire or a wire that goes through this lamp, for example, we create a path for the electric charge to go through, right? Because we have this electric charge that is moving inside this wire, that results in having a current inside this medium, the wire, right? So that is the distinction between voltage and current. So now that we have this, let's just go through the definition of voltage. So the voltage is defined as the energy per unit charge that is created when positive and negative charges are separated. So in effect, when you, let's say, work with an atom, for example, right? You have some positive charges inside the nuclei and you have some electron negative charges that surround the nuclei, right? So the atom by itself is neutral. If you make an effort to separate the positive and negative charges, so the amount of energy per unit of charge that you spend, that you can say it's been stored in that atom as a voltage, right? Of course, my analogy is not 100% accurate because here we don't talk about how the voltage is created, right? In practice. Here we want to see how the voltage can be defined based on the parameters that we know, based on the variables that we know. So the energy per unit of charge that is created when positive and negative charges are separated, that is what is called as the voltage. So based on that, we have voltage here, which is defined as the derivative of the energy with respect to the electric charge. So V equals dW over dQ. The derivative of energy with respect to the charge. So that was the definition of the voltage. What about the definition of the current? So for the current, since the current is created as a result of motion of electric charge, the current is defined as the time rate of change of charge flow, or more specifically as the derivative of charge, electric charge, with respect to time. This results in current. So again, I, or current, is the derivative of electric charge over time. So the amount of electric charge that is displaced over time. So that is what is called the current. In this video, we learned about the electric charge and we talked about its basic characteristics. And also we learned about the voltage and current, both what happens in terms of electric charge to create voltage and current, and more specifically, what is the equations that describe voltage and current.